All right, welcome to the first video of section 7.1. In this section, we're going to be talking about direct variation and inverse variation. So before we look at some problems and identify whether or not those variables show direct variation or inverse variation, let's look in your journal and look at a quick definition of what direct variation is. So we've got here, this is on page 192 in the core concepts. Two variables, x and y, show inverse variation when they are related as follows. So we've got y equals a over x when a cannot equal 0. So a can equal any non-zero number. So what that means is if your variables are related in this way, such that y is always equal to a constant divided by x, then we say that those show an inverse variation. We call a the constant of variation, and we say that y is said to vary inversely with x. So y is said to vary inversely with x. Now, let's look at a couple examples here. These examples are going to show you three different situations where we've got inverse variation, direct variation, and neither. So let's go ahead and look at them. So here's our three equations. We've got xy equals 5, y equals x minus 4, and y over 2 equals x. Now remember, what we're looking for is, in order for inverse variation, we want y to equal a over x. That's what we want. We want y equals a over x for inverse variation. That's inverse variation. So let's go ahead and look at these first ones. So let's go ahead, we're going to write down what we want to do is, in order to decide whether your variables show either direct or inverse variation, we need to solve for y. That's always the first step. So let's start with part A. So we've got xy equals 5. So in order to solve for y, we're going to want to take both sides here, and we're going to divide by x. So divide both sides by x. So we're going to end up with y equals 5 over x. Now, that fits our inverse variation. We've got y equals a constant over x. So this is what you're looking for inverse variation. So when your y value is equal to a constant divided by x, that's inverse. Okay, let's look at our second, y equals x minus 4. Now that's our given equation. Now in this case, we're already solved for y. Remember, solving for y is just isolating y. So we've got y equals x minus 4. Now that doesn't follow our inverse variation pattern or our direct variation. So that would be neither. Now, in this case, in our last one, we've got y over 2 equals x. Now to solve for y, we're going to multiply both sides by 2. So we're going to multiply by 2, and these cancel, and we're going to get y equals 2x. Now, in this type, because y is always going to be twice as big as whatever x is, we say that that's a direct variation. So y is just equal to a times x, so a constant times x. So your two keys right here, your keys are for inverse variation, so inverse variation and direct variation. Here's what your two formulas look like. Here's inverse and direct. Inverse is going to be y equals a over x, and direct variation is when you have y equals a constant a times x. So you can see the difference between the two here. We say that x and y show inverse variation if they fit this form, and direct variation if they fit this form. And if they're neither of these, such as in this case B right here, when you've got x minus a number, then you just say it's neither. Not every equation has to be one or the other. They have to fit this specific model to be counted inverse or direct. All right, so what I want you guys to do here to practice a few of these, let's go ahead and I want you to look at this example right here. I want you to look at A, B, and C and go ahead and answer A, B, and C. You're going to answer them all in the same text box, but make sure you label them. So I want you to state whether they show direct variation, inverse variation, or neither. So just go ahead and answer all three of those there.